Hello, dear viewer, and welcome to our team's design presentation for a thermal reactor for MECH 3820 heat transfer. The design for our thermal reactor was broken into two separate projects. The first project analyzed conduction, and its goals served to recommend the best material and gases that the reactor should be made up of. 4 different layering designs were looked at and calculated in hopes to find the best insulation. For the combinations, the first material mentioned is the material of the electrode, which stayed constant throughout the project. The second material is the gases, which flowing through the reactor itself. And the third material is the material that made up the reactor wall. The selected material combinations were as follows: steel, air, resin, steel, air, and quartz, steel, hydrogen, and resin, steel, hydrogen, and quartz. The steel, hydrogen, quartz combination proved to be the best insulation. However, due to hydrogen being explosive, air was selected as the preferred gas. And quartz, while proving mathematically to be the best material for the wall, was not recommended due to its brittle nature. Pyrocerum 9606 was chosen in place of quartz as it is less brittle and has a similar thermal conductivity. The second project for the thermal reactor design was to analyze and find ideal flow conditions for externally with convection, internally with convection, and internally with annular flow. For the external convection, 4 environmental conditions were observed via calculations. They were a low temperature and high winds condition, 2 moderate temperature and moderate wind speed conditions, and a high temperature and low wind speed condition. Of the tested environmental conditions, a temperature of 30 degrees Celsius and a wind speed of 30 meters per second provided the lowest heat transfer rate without being negative. For the internal convection, nitrogen and hydrogen were observed at 4 different temperatures. The total rate of heat transfer was obtained for each condition, and the gas with the lowest heat transfer rate was selected for use. In this case, it was found to be hydrogen. For the internal annular flow portion of this project, various different conditions of ammonia was tested via calculation, ranging from low to high flow rate, as well as low to high electrode temperature. From this portion of the project, it was found that the flow rate of ammonia should be set to as low as it possibly can. Rather than nitrogen, hydrogen should be used due to its having a low heat transfer rate. This in turn would result in less heat being transferred from the reactor. Finally, a high hydrogen flow rate would be needed. Thank you all so much for your time, and I hope you enjoyed our team's presentation.